probability in fraction form. There's the numerator and the denominator. What does the numerator represent? What does the denominator represent? And to help you answer this question, I'll ask you, if you flip a coin, what's the probability that you get heads? 1/2. What does the 1 represent? Nope, not the chance of it happening. Nope. The number of outcomes that you want, exactly. So the top is the number of desirable outcomes. And what's the bottom going to be? Total number of possible outcomes. Exactly, right. So if I flip a coin once, how many outcomes are there? It's either heads or it's tails. So how many outcomes is that? That's 2 outcomes. How many of them do we want if I said, what's the probability of getting a heads? There's 1 of them. So there's 1 out of 2 chance. There's 1 out of 2 chance. So I asked you originally when we started this topic, I asked you, what about when you flip a coin, what was it, 5 times? Yeah. I asked you 3 things. When you flip it 5, so 5 times. I asked you, what was it, no heads was the first one, I think? Was that the first one?
No heads, 1 head.
Yeah, so it was no heads, 1 head, 2 heads. Right? Do you remember what no heads was? Do you remember what that probability was? What? It's impossible to flip no heads. 1 over what? 1 over 32. Do you remember where 1 over 32 came from? There's 32 different outcomes, and how many of them are no heads? 1 of them. How many different ways can you get no heads? There's only 1 way you can get no heads. What is that? They're all tails. Tails, 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 tails. And there's 32 possible because, do you remember this? If you, again, we're not saying it's landing on its side. If you flip a coin 5 times, each time you flip it, it could be either heads or what? Tails. So you have tails or heads, tails or heads, tails or heads, tails or heads, and I know tails or heads. So each one of these is 2. So each one of them can have 2 different outcomes. So what do you do with all of these numbers to find the total number of outcomes? Multiply them. What's 2 to the 5th? So when you flip a coin 5 times, how many different unique outcomes are there? 32 of them. How many of them are no heads? 1 of them. How many different ways can you get 1 head? You can either flip it the first time or the last or the second or the third and fourth or fifth. So how many different ways can you flip 1 head? And how many different ways can you flip the coin total? 32. So the chance of getting 1 head is 5 over 32. So then I asked you to do 2 heads. This was harder to count. Do you remember writing out these strings? It was a little harder to count these. So when you did 2 heads, you did what? Heads, heads. Like here's one of them, right? But then you could have tails, heads, heads, tails, tails. What's another one?
Tails.
Tails, tails. Remember, do it in a pattern. Heads, heads, tails, right? Or tails, 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 heads, heads. But then could those heads be broken apart?
Yeah.
So was it hard to count them?
Yeah.
Yes. These questions with regards to probability and counting can get pretty tricky pretty quick. They can get pretty tricky pretty quick, mainly because I haven't armed you with some math tactics that help, but right now we have to rely on counting. Do you remember how many different ways there were to get 2 heads? Do you remember? There were 10 of them. There were 10 ways to get 2 heads. And how many ways total are there to play this game? 32. So the chance of getting 2 heads was 10 out of 32. So this is the question I want to ask you next. What about 3 heads? I'm going to give you 1 hint on this. 2 hints, really. 1, you might think that this would be a lot more because it's gone 1 out of 32, 5 out of 32, 10 out of 32. It's not a lot. Oh, did you answer this one already?
Yeah.
Oh, we did. Sorry, we answered this at the end of the last class. I'm sorry. So what is it?
10 over 32.
Why is it 10 over 32?
Because getting 3 heads is the same thing as getting 2 tails.
Yeah, 3 heads. That exactly. I'm sorry. Is 2 tails, and 2 tails is the same thing as 2 heads. It doesn't really matter heads or tails. So 3 heads is the same thing as 2 heads. So it's going to be 10 out of 32. So let's keep on doing this. What about 4 heads? Same thing as 1 head, right? because 4 heads is the same thing as 1 tails. So what's that going to be? 5 over 32. Exactly. And so we have no head, 1 head. So when I flip coins, this is the point I'm trying to make here. I know, you'll notice it. Ready? When I flip a coin, there's only 5 different outcomes, really. You can get no heads, you can get 1 head, you can get 2 heads, you can get 3 heads, or you can get 4 heads. There's one last one, though, right? What else could I have? What else could I have? 5 heads, right? And what's that going to be? 1 over 32. Are there any other possible outcomes that we haven't accounted for? What happens when you add up all these fractions?
32.
They equal what? 32 over 32. These are all of the outcomes, so they have to add up to 32. My point is, you can also calculate the probability of something happening if you can calculate the probability of it not happening. The probability of something happening plus the probability of something not happening, what's it always equal? 1. Does everybody understand what I just said? The probability of something happening plus the probability of something not happening equals 1. Sometimes it's much easier to calculate the probability of something not happening and then subtracting that number from 1. Let's do an example. So coin flippies. How many different ways can you flip a coin 10 times? How many different ways can you flip a coin 10 times? 2 to the 10th, right? And 2 to the 10th is a big number. What is 2 to the 10th? Can someone? So that's 1,024. So when you're dealing with so many different outcomes, if I ask you any questions about any probabilities about flipping a coin 10 times, do you have to be really careful? Yeah. With 1,024 different outcomes, do you ever want to make a list that long? No. I will never have you make a list that long. That is too long. So let's answer some questions about this, though, that we can do by doing that thing where we find the probability of it not happening. Okay? So here's a question for you. Probability of never getting 2 heads or 2 tails in a row. The probability of getting, do you understand that we're getting a string of heads, heads, or tails, tails? What's the probability of getting heads, heads, or tails, tails? Yeah.
1,022.
What?
1,022
over, correct, equals the probability of getting HH or tails, tails somewhere in the string. Is that a really high likelihood or a really low likelihood? That's a really high likelihood. That's really, really close. It's like 99.99%, right? Okay, so